We're all aware of the requirement to keep pesticides out of our water courses, and there are plenty of safeguards in place to help us to do that. But compliance with buffer zones is a fundamental part of the Sustainable Use Directive. So buffer zones apply to all water bodies and are measured from the top of the bank where that red and white pole is there. Now these buffer zones on pesticides can be as small as 1 metre or can be as wide as 30 metres. But typically a lot of these are 5 metres. But details on the buffer zone requirement for each product is on the label. Stripe, or surface water tool for reducing the impact of pesticides in the environment, is a mechanism that we can use to reduce these buffer zones. So there are 3 ways that we can reduce the buffer zone on a pesticide. One is by using department approved drift reducing nozzles. So these nozzles can reduce drift by 50%, 75% or 90%. But we can also reduce the buffer zone by reducing the rate of the product applied. And thirdly, we can reduce the buffer zone by a combination of using drift reduction nozzles and reducing the rate. But it's very important to consult the PCRD website when using drift reduction nozzles to work out the exact buffer zone requirement. And finally, it's very important to mention that there are safeguard zones around drinking water abstraction points, and these can range from 5 metres out to 200 metres. But Stripe does not reduce these buffer zones.
On modern crop farms, the spend on plant protection products, fungicides, herbicides, insecticides can range anywhere from €150 per hectare right up to €300 per hectare. So it's important that we get those products applied to the crop evenly and accurately, and that's the role of the sprayer. And on the sprayer itself, probably the most important component is actually the cheapest one or the least expensive one, and that's the nozzle tip, because the selection of the right nozzle will determine the correct water application rate, the correct application rate of the chemical itself, and the correct spray distribution on the plant itself. So correct nozzle choice is hugely important. So where do you start? How do you select the nozzles for your sprayer? The first protocol really is the label of the product itself, because it will give guidance in terms of the required water volume per acre or per hectare, and also the required spray quality or spray size distribution. So that's the starting point. And then when that's decided, we can pick nozzles, and today the nozzles are actually all color coded. So these blue nozzles are a particular size and a particular output. So we can pick the nozzles and fit them to the sprayer. Whereas the choice is often between the type of nozzle, a standard flat fan nozzle or a low drift nozzle. This one here is actually an air induction nozzle, and this nozzle, by taking air in as the chemical is being applied to the crop, it changes the size distribution of the droplets hugely. We have much larger droplets from this, much less prone to drift, and much more better targeted on the crop itself.
Okay, so I just want to talk a little bit about nozzle choice and the effect it has on drift. I suppose first thing we need to do is just kind of understand what drift is. Drift is, any particles of our spray that are not landing in the target location. So obviously, as we're driving across the field, we're spraying down and we're trying to hit the crop or the ground or whatever our target is. If we have drift, that some of our particles are moving away from that location and they're going to land somewhere else. Where it becomes more of an issue is obviously the closer we get to a headland or a boundary. In that case, then any drift that we have will tend to go beyond the boundary and may end up in watercourses, and that's how that's why we need to control drift, and obviously more importantly control drift the closer we get to a boundary. Here we're just looking at our standard flat fan nozzle and the AIXR nozzle from TJet. So the AIXR nozzle, this is an air induction nozzle, and the XR is extended range. So basically what this nozzle, it has 2 orifices. It has an orifice here at the back and a second orifice here at this end. So the orifice here at the back is actually controlling the flow of the liquid into the nozzle, and then the outlet here at the top controlling the actual droplet size. Now we also have two inlets here on the side of it, so this is actually taking air in to the nozzle here, and it's actually mixing with the liquid inside, and it's actually forming a coating around a bubble of air to increase the droplet size. Okay, so we're just going to take a look at, we'll start here with our 04 red nozzles, and we'll just have a look at the spray quality from those. First one we're going to start with is just our standard fan nozzle. So we have our standard fan, you can see we have our 110 degree fan. So we're getting a relatively small droplet size. We are getting a little bit of drift, better, but there is a certain amount of drift floating away here behind us. So if we change over to the AIXR, so the air induction, you can see the droplet size now has actually increased quite dramatically. The amount of drift from behind, we're still getting a very small amount of drift coming away from behind it, but it's greatly reduced. So those droplets, again, we're getting the same application rate, so it's the same rate of liquid that's coming because this is still a red nozzle.
So the air induction nozzles can be used in most situations, but the droplet distribution size is different, so they're not perfect for all situations. Where your target is very small, such as with a small grass, for instance, with a herbicide, you would be better with a standard nozzle than this. So for most growers, the best option is actually to fit both types of nozzle to their sprayer, to their nozzle holders. So if they're both a blue O3 nozzle, it means they can switch from a low drift nozzle to a standard nozzle, and vice versa, depending on the weather conditions and the crop situation that you're doing, without influencing anything else in terms of the calibration, forward speed and so on. So to have both types of the nozzle at the same size on the holder is the best option.